For years, the AI industry operated on the premise that more parameters inevitably led to better models. But scaling these massive neural networks eventually hits a hard computational limit in physical processing space. In mid-May 2026, Google responded to this hardware reality by releasing Gemini 3.5 Flash. Rather than forcing further expansion, the model represents a deliberate pivot towards structural efficiency. This schematic dashboard shows the core technical specifications: a 1 million token context window, an up to 4 times speed multiplier, and native multimodal processing. It is built specifically to handle coding environments and agentic workflows. These specifications allowed the model to immediately become the default engine for the Gemini app and the broader Google ecosystem, replacing heavier models that require more compute to run. The design of 3.5 Flash suggests that the next stage of AI utility depends on how quickly a model can act and how much it can remember while doing so. To see why that speed matters, we have to look at an agentic workflow. This is an AI operating autonomously, moving through multiple sequential steps to achieve a complex goal without human intervention. When you run an agentic workflow on a standard, parameter-heavy model, you hit a processing delay at every single step. Waiting for the model to think creates compounding delays that break the flow of the task. These compounded delays prevent real-time software execution. A system cannot function effectively if it pauses for 30 seconds between every individual subtask in a live environment. Memory limits create a secondary failure point. By the time a standard model reaches the 5th or 6th step of a multi-part operation, it frequently loses track of the initial instructions, leading to execution errors. Gemini 3.5 Flash was engineered from the ground up to solve these specific mechanical failures, prioritizing processing speed and sustained memory over raw parameter count. This split-screen flowchart shows the optimized architecture of Gemini 3.5 Flash. Stripping down weight yields a massive operational gain, operating 4 times faster. This speed is structurally vital. As the pipeline splits into overlapping subroutines, it becomes the only way to manage autonomous code. A single autonomous agent task, like updating a cloud database, requires several invisible microqueries. The model must plan the task, retrieve the relevant data, and draft the initial code. To execute that code safely, it must perform self-verification and error correction before finalizing the request. If a standard model takes 5 seconds to process each prompt, those 5 invisible microqueries create a 25-second delay for the user. In most software environments, that latency causes the system to stall out and time out before the initial request is ever completed. The Gemini 3.5 Flash architecture prevents this failure. The 4 times speed multiplier absorbs the weight of all 5 microqueries, allowing the entire sequence to occur within a standard response window. This allows the model to constantly verify its own code outputs in real time, catching errors as they happen rather than after a crash. High processing speed is the foundational prerequisite for an AI to transition from a passive text generator into an active, independent agent. This grid visualizes the 1 million token context window, holding vast volumes of unstructured data simultaneously. In software environments, these pillars represent entire corporate code repositories loaded at once. This tracks relationships across thousands of files, ensuring an edit doesn't break a dependency. Combining this memory capacity with high-speed multimodal input allows the model to act as a stateful agent that maintains deep awareness across complex workflows. We can see this engineering in action by surveying the features announced at Google I/O 2026. These product updates function as expressions of the shared engine at this network center. The first node, Google Beam, uses this engine to enhance group meetings. Synthesizing conversations requires the 1 million token window to hold multi-person transcripts in memory simultaneously. Google Beam requires the model's speed to process transcripts instantly, avoiding live call processing delays. The second node, representing Chromebook accessibility tools, highlights a different technical requirement. Multimodal capabilities power features like real-time face control, where the model interprets facial gestures through the webcam to navigate the screen. For face control to be functional, the system requires near zero latency between a user's movement and the computer's response. The 4x speed multiplier provides the instant responsiveness needed for hardware interaction. Finally, Asset Studio brings these capabilities to AI-powered creativity. Asset Studio utilizes the massive context window to absorb and retain corporate style guides, maintaining strict brand consistency across complex ad campaigns. Without that memory retention, generative tools eventually drift off-brand or hallucinate details over the course of a persistent workflow. These features rely on the specific engineering trade-offs made within the Gemini 3.5 Flash architecture to exist reliably at scale. Making 3.5 Flash the default model across Google services reflects the operational reality of global-scale AI. Deploying any AI model to billions of users creates an immense continuous computational burden. Using slower, heavier flagship models for every search or draft risks overloading the underlying server infrastructure. The extreme efficiency of 3.5 Flash solves this scaling problem. It provides high-tier agentic capabilities without levying an unsustainable compute tax on the data centers. Architectural efficiency is the only way to provide high compute features across a global network. The industry is moving past the assumption that building larger models inherently results in better ones. The May 2026 rollout marks a transition towards optimization over pure scale, establishing the foundational infrastructure required for autonomous agents. A model optimized specifically for rapid execution and massive context retention is more effective for daily, practical computing than one built for scale alone. The engineering behind Gemini 3.5 Flash serves as the blueprint required to move autonomous AI workflows out of the laboratory and into the real world. This shift indicates that AI is transitioning from the conversational novelty into a high-speed utility powering the developer ecosystem.